Okay, so today we're going to continue working with the end behavior models. And so we saw how to find an end behavior model, g of x, okay, for an f of x. And we saw the long way to do it, and we saw the shortcut way to do it. Now we're going to actually prove that g of x is indeed the end behavior model for f of x. Okay, and sometimes we have to do it for when it's both a right end behavior model and a left end behavior model. So that means that we kind of have to explore our functions a little bit. So let's actually take one step at a time and notice that it says show that g of x is both a right end behavior model, so I'm going to abbreviate right end behavior model, and a left end behavior model. Now, I'm sorry that I cut off part of the slide. It does say right end behavior model. Trust me. Okay. When it's the right end behavior, we want to take the limit of f of x divided by g of x as x approaches positive infinity, okay? And when we do the left end behavior model, we want to take the limit of f of x, this is so long I have to just write the function, over g of x as x approaches negative infinity, okay? So since it's both right and left end behavior, then you can actually combine this particular problem. But in other words, if there is a different function for the right end behavior model, like that one's g of x, from the left end behavior model, let's call that h of x. You have to do both limits. So I apologize if that is the case. But for right now, to get our feet wet, luckily it's just the same thing, okay? Okay, so here we go. I'm just writing out f of x over g of x. And so I'm going to divide each term by the 3x to the fourth. So that means that I'm just kind of simplifying my algebraic expression. I'm getting 1 minus 2 over 3x plus 1 over x squared minus 5 over 3x cubed plus 2 over x to the fourth. Okay. So now if we're taking the limit of each term, and I have to kind of squeeze this all in. This is a good one because we know that as we do the limit of c over x to the r, whether c is 2/3 or 1 or 5/3 or 2, as x approaches positive infinity or negative infinity, these all become 0. So basically, just have to worry about this limit. The limit of 1 as x approaches positive or negative infinity is 1. So we end up getting an answer of 1. That's what we want when we have to show that it's both a right end behavior or a left end behavior. We want the answers of 1, and that was part of our definition for an end behavior model. Okay, now I'm just going to give you a heads up. If you are dividing by something here, let me point this out, and it comes out to a function that you have no clue what you're looking at if you had to do the limit, then it is something that you should probably do graphically, okay? take a look at the graph of that function and determine what the limit is. So that may happen a lot of times when you have a g of x for the right end behavior and an h of x for the left end behavior. So if this is something more complex than our rule that we know that it's 0, determine its limit graphically or numerically. So that way we can evaluate what that is. Okay, and hopefully it turns out something that will help us compute to 1, or calculate to 1, I should say, because that's what we want as our final answer. Okay, so let's do some practice and good luck.